Hello there, everyone. The subject of this video is very simple. Just please help me to test my sun calculator that I made on this spreadsheet. But before I go into the details of how to use it, I'd like to give a brief history about how this something became to be like this. Well, first of all, I started by building something like an equatorial mount, as you see there, and I did some tests for it, tracking the sun many days along different times of the year, and it worked very well. And then I took some reading from that, if you would like to call it, equatorial mount, and then I put them into analysis. As you see, this is just a better drawing of how it would look from front view. And then, based on analyzing the triangles of this equatorial mount, I built my first sun calculator, which, as you can see, it's very, very simple. And here is a note that the equations or the sun declination angle will not be accurate because I'm using a circular orbit for the Earth. So this was the first version that I can find. The earlier version didn't even have a sun declination angle. I had to go to time and date and put it in here. Now this was a later version, which is still not like the current one because I used to put only the latitude line and the longitude line wasn't there. So back to this latest version right here. First of all, we have here a few few sheets. First one is interfaces. This is the only one you'll need to use. The second one is the equations that works with it. And it's so messy and I cannot fix it. I'm sorry for that, but you will not need to use it anyway. The third sheet is is for my use only, or maybe in later episodes I can show how to use it. You have, excuse me. You have to bring these numbers, the perihelion and the winter time, accurate time from time and date, because these numbers goes into the equations. The third sheet is the analemma, and the final sheet, it's not really connected to that. It's about graphing the stellar aberration. But anyway, we have here the right side for inputs and the left side for the outputs. And please take this note: the spreadsheet formula cells are not protected, so be careful where you're going to type anything, and generally don't type anything except in these fields with this yellowish green color. So these are the inputs. These are the main inputs that you will need to use. You put the day, you just type the day and months and months. You don't have to put the year. And if you put, like, for example, the 1st of April, it will come like this. I'm sorry, you cannot fix it, and it comes as quarter. So you have to say 104. That's the 1st of April. The same goes with March and maybe February too. So that's the first thing you have to be careful with. The second thing is latitude and longitude lines, and plus and negative degree, point degree. So here you put the latitude, and here you put the longitude, this here in the northern hemisphere, and this here is to the east of Greenwich. And right here I just put a simple converter if you have minutes in degree in minutes and seconds, this can convert it for you, and then you copy it and you put it here. And as you see, this is in yellow. This means this is an output. Try to avoid input anything in it. The last part of inputs, or the main inputs, is the time in 24 hours format. So this is 12 noon. This is to get the measurements of the sun at a specific time. And it only works within daytime only. The second part is supplementary inputs, like geometrical corrections. You shouldn't change this if you need the best results or accurate results, but I just leave it here for experimental, because it includes the refraction and the sun radius. The sun radius is 0.26 degrees, and that's not where you measure the sunset and the sunrise. I mean the center point of the sun. So this 0.26 is just to correct the calculations into taking into account the center of the sun instead of the upper edge during sunset and sunrise. So if you need to remove the refraction, then you just come here and type 0.26. 0.26. That would be working without atmosphere and without refraction. So these are the inputs. Now, before I forget, this here, and this here. This means that this input affects only this part of the calculator. So what outputs do we have? The first thing is the solar noon. The second is the sun elevation on zenith. And then the day length in hours and minutes. Sunrise, time and azimuth. Sunset, time and azimuth. And then the lower part of this calculator is only for this section if you want the sun elevation and azimuth on a specific time. So if we say 10 a.m. at 10 a.m. that's before noon, the sun azimuth will be 45 and the sun elevation will be 52. And this here indicates that the time of reading is 1 hour 0.7 before the solar noon. Now, if you wonder why this area is blank like this, this is because the biggest problem that I faced making the spreadsheet is not the geometry or the math. It's making the spreadsheet understand what I want it to do. So this was one of my problems. So for example here, if we go to, let's say December, the 2nd of December. Now you can see what's the point of this. So go to different locations and compare to time and date. Use your own town or own location and use various times during the day time, and check the results and compare them to whatever tools you have, and try to be as picky as you can. I mean, don't go easy on me. I want to find every mistake, even if there are mistakes that I already know. I'd like to see people pointing them. I didn't study astronomy or have a degree in math or anything like that. Just pure research and analysis, and a little bit of looking into just Wikipedia for a little bit of orbital mechanics and ellipses geometry. And that's the final results. So I hope you do the test, and if you have any suggestions, I'll be glad to hear them, and maybe I can do it. And thank you.